up?
CJ.
And this is our paper bridge project. So the history of the trust, so we decided to do the Warren Trust, and it was patented in 1848 by James Warren and Mr. Manzani. And why we decided to do this trust was because we knew that if we did vertical cross members, that it would be pushing down and the members would be more likely to fail. So we decided that we wanted to go with an equilateral triangle to make it so that it was more stable. And we decided to do this because it was simple and it made it very easy because it didn't have lots of complex joints. So some of our preliminary sketches. These were the trusses and like the names of them that we decided when we were like designing which one we wanted to do, but we ended up going with the Warren Trust.
Right there, and we knew if we did this, if we did that with the vertical members, it would press down on the horizontal one, producing a failure, meaning it won't hold any weight.
And this is our computer testing. So for West Point, it helped us to know that which ones were like in tension and compression, and when a load would be passed over the center where it would fail. And then MD Solids gave us a good test of if 50 pounds were actually on it, how much each like member would need to hold. And this is our final sketch. And the things that we predicted that would fail would be the joints, mainly because the joints of how we decided to do it. We later realized that it wasn't the best way to do it, and we could have done it a better one. But we also thought that the bottom member right here would fail because that was under the most tension.
Okay, well, with our joints, we realized that we wanted the whole bridge in compression, and that's not the way that bridge is designed because parts of it are that are tension. So we figured out that basically the members were just going to slip right out of the joints, and after the fact, and we went, okay, now if we're going to redo this, we need to go and find a way to actually secure the joint to the member so that if it was to be pulled, they wouldn't pop out.
So this is the actual bridge. Our bridge weighed 255 grams, which was 150 under the limit, which, given like the reflection of it, we could have added a lot more like paper around the joints to make them more strong, but the members overall weren't the problem. You want to click that thing?
Click it again. Up to the next
One view.
Yeah, it's me. So this is the video of it breaking. You know what? I have to cap it. So right off the start, one of our joints broke right over here. So we knew that from the start that it was going to continue to like fail at the joints, and the joints were going to be what makes us like not be able to hold the weight.
When that joint actually failed, it initially failed when it separated from the bottom member, but there was actually still like dried glue that stuck from the joint to the member, and that actually held quite a bit of weight, and then it all of a sudden just snapped.
Where's the snaps?
There's no like
I wanna see
big
it
break.
die.
It just the like joints pop off from the members.
Dude, there was a little
Pop-out.
shift.
Oh, okay, sounds that interesting.
Weird.
I mean, it's great.
So, yeah.
I like it.
So overall, it held 26 pounds. And this is the graph it showed. Right off the bat, this first like joint broke, and then it continued to break until it got to where the whole like truss could not support itself anymore. And this is the after pictures. This shows, you can kind of see it. It's kind of hard, but this is not attached at all. The other joint is though, and on these vertical members, these we did not think that they would be like under tension, but they were actually being pulled apart, which made them slide out a little bit.
have noticed, there was a member here that actually really helped secure this and that. And when this failed, that failed, and the whole bridge just went, and then these popped out, and it just went downhill.
So reflection, what we could have worked on, the concept overall we thought was a successful concept, and we could have continued to like use that, but given more time, we should have made it better. And the members overall held the way that they were supposed to. It was just the joints that failed. So what like didn't work was just pretty much the joints in general and securing the cross beams. And if we were to do this project, what would we have done differently? We would have focused less time on testing the actual members and seeing if those held, more time testing the joints, because those are the true things that what brings down the bridge.
Yeah. Clap, clap, clap. Turn you off now.